In the previous video, we saw how the reward was part of the environment. In this video, we will talk through the nuances of designing an effective reward. Providing the proper reward structure is essential to the reinforcement learning problem. The agent, as we will see, is great at maximizing the reward function. This is part of the beauty of reinforcement learning. It's also part of the downside. The agent is only good at maximizing the reward function. It can't read our minds and discover what we actually wanted it to do. This means that if you don't structure the reward properly, you can get somewhat unexpected behavior. If we're talking about simple games, it's not really a problem. However, when these systems are employed in the real world, safety can be a big concern. While a complete discussion of the safety of artificial intelligence is beyond the scope of this course, we should always keep in mind to make sure what we're asking of the agent is what we really want. The first step is defining what a reward is exactly. For humans, rewards are generally something pleasurable, a vacation, a pay raise at work, or just positive reinforcement from your peers. More technically, a reward is the release of certain neurotransmitters in your brain. For now, artificially intelligent agents don't have biological brains, so our conception of a reward must be changed. Instead, we can use a simple numeric scoring system. Points are assigned for actions we want and can be subtracted or not given at all for other actions. With that in mind, we can start to think about the reward structure for a maze-running robot. One possibility is to award a point each time the robot solves a maze. After all, we want the robot to solve the maze, so this structure seems to make sense. But what would only giving a point for solving the maze incentivize, really? Consider this. If we're not measuring the number of steps required to solve the maze, how can we tell if the robot is learning? As we saw in the last video, the maze we've designed can be solved in 10 steps, so a good maze runner should get something close to that. If we only give the runner a point for solving the maze, how will it know to do it in as few steps as possible? Think about it. If it gets the same reward for solving it in 10 steps as it does in 10,000, will it be in any hurry? Unlikely. All of this is to say that our assumption of giving the robot a point for winning, and only a point for winning, is the wrong choice. The better choice is to subtract a point for each step the robot takes, except for the final step where it exits a maze. It will then get the idea that it needs to minimize the number of steps through the maze and can actually get better at solving it. Another potential pitfall in designing the reward is overspecifying the ways in which the agent can receive a reward. Consider the game of chess. If you're not familiar with it, it's a board game in which two players control pieces that can move in different ways. The game is won when the opponent's king is under direct attack, called check, and cannot execute any legal moves to escape, called checkmate. Suppose you're trying to design a system to play the game of chess. You might be tempted to give the agent a reward each time it captures a piece. After all, the best players often capture most of their opponent's pieces. Makes sense, right? However, this can lead to some problems. It's possible to capture all but the opponent's king and queen and still lose the game or draw. It's also possible to capture pieces at the expense of controlling the board, which can lead to a loss down the line. You might also be tempted to subtract points for losing your pieces. However, there are many cases in which sacrificing a piece can set up a win in just a few moves. This would effectively cut out an entire class of highly effective strategies. The point here is to keep your reward as simple and direct as possible. Don't try to tell the agent how to solve the problem. Rather, set up a proper reward structure that lets it discover its own strategies for winning. It may surprise you with its ingenuity. That wraps it up for this video. By now, you should see how nuanced the design of the reward function is. Since the agent only maximizes the reward, you must properly incentivize the agent to perform the desired actions. And finally, don't dictate how to get the rewards. You can end up cutting off entire sets of strategies that would otherwise yield great results. In the next video, we're going to connect the rewards to the agent with the value function.